All right, we're going to continue practicing here. So our top one, we've got calcium and bromine coming together. Calcium's a metal, so this is going to be an ionic bond. So there would be no picture, no molecular shapes, no molecular structures here. All right, so we name our first substance. So we have calcium. Bromide becomes bromide. Calcium does not require a Roman numeral because he only has one option. You're done. Calcium bromide, binary, ionic. Okay. Second one, CCl4. Carbon and chlorine are both nonmetals, so we are going to share here. So this is molecular. So carbon tetrachloride is the name of my substance. All right. So we've got 4 on the carbon. We've got 7 for chlorine. Times 4 is 28. There's 32. That's 16 pairs. So I'm going to 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then that gives me my 16 pairs. All right, so we've got non-polar covalent here. You can see that. We've got tetrahedral on the shape, which is going to give us a 109.5 bond angle. And then in terms of hybrid, we have S, P1, P2, and P3, so it's an sp3 hybrid. All right, the next few here are acids. They start with H's, they're acids. I don't want us to worry about drawing the structure, I just want to worry about naming them. So our very first substance, we have H2SO4. So this is an oxyacid because you see a polyatomic. So SO4 is sulfate. Remember, 8s go to X. All right, and sulfur and phosphorus are weird that they actually put the R's back in when they go to an acid. So instead of sulfic, this becomes sulfuric acid. Okay, our next one starts with H, still an acid, and it is an oxyacid again. So we look at the second part is sulfite. So ites, you can see that, go to OUS, and still sulfur, so we put that R back in. So this becomes sulfurous acid. Okay, and then the last one down here, we're dealing with a binary acid. Okay, so it becomes hydro instead of sulfide, sulfuric acid. Now, this one I am going to go ahead and draw the structure on. These two I wouldn't because they're going to be a little bit tougher than what you would see on your assessment, so I left them alone, but this one I will do. All right, so hydrosulfuric acid, I've got 2 from the hydrogen, 6 from the sulfur, that's 8 electrons, 4 pairs. So I'm going to go 1, 2 for that, 3, and 4. The lone pairs are going on the top of the sulfur. This is going to be bent, 104.5. It's definitely polar. Okay, because you've got this side right here that looks different than the other side, so polar. And then we've got S, P1, P2, and P3, so this is an sp3 hybrid.